Hello everyone, my name is Nidhi Singh. I'm assistant professor in Gyan Vihar School of Pharmacy. That is a part of your Suresh Gyan Vihar University, Jaipur. And today we will discuss the topic that is a carboxylic acid. And in the last lecture, we have already discussed about the carboxylic acid derivatives, in which we have already discussed the physical property. So this carboxylic acid is in pharmaceutical organic chemistry first, and here is the learning objective of this topic. So in this, the learning objective, today we are going to learn about the carboxylic acid derivatives, and also we are going to study about the preparation of carboxylic acid derivatives, and also we are going to study about the chemical reaction of carboxylic acid. And the student outcome is that they are going to know about what is carboxylic acid derivatives and what will be the method of preparation of carboxylic acid derivatives, and also we are going to learn about the chemical reaction of carboxylic acid derivatives. So in the last lecture, I have already told you that what is the physical properties of these carboxylic acid derivatives and what comes under the carboxylic acid derivatives, and also the method of preparations of this carboxylic acid derivatives. So a few of them were discussed. So today we are going to see the left one, the which were left from discussing from the last lecture, and also we are going to learn about the chemical reactions of this carboxylic acid derivatives, that how the chemically these are reacting with another reagent and forming the other products. So here we are going to learn about these things. So let's start the topic. So in the starting topic, we are going to learn about the introduction. So here the introduction is that the most important functional derivative of carboxylic acid, acyl chloride, acid anhydride, esters, amides, which are obtained by the replacement of OH part of group of acid by my Cl, OCOR, OR dash, or NH2 group respectively. So here the carboxylic acid derivatives means these are derived from the carboxylic acid, and the carboxylic acid is also a mixture of your carbonyl function group plus your hydroxyl group. So both of them mixes or add up. After that, there is a formation of this carboxylic acid. So in this carboxylic acid, you can see there are two forms are mixed up. One is your carbonyl, that is your CO part, and COO part, and the hydroxyl, that is your OH part. So in this, the COO and the OH part is making the carboxylic acid. And these derivatives, these are derived from this carboxylic acid. So from this carboxylic acid, this hydroxyl group part is removed from this side, and after replacing this OH by the different functional groups, they are forming the derivatives of this carboxyl because they are attached to the carboxylic acid. So they are known as the derivatives of the carboxylic acid. So here the most important functional derivatives of this carboxylic acid are the acyl chloride. So this acyl chloride is the important functional derivative of this carboxylic acid anhydride. After that, acid anhydride is also an important derivative of this carboxylic acid. And the third is your ester. So ester is also an important derivative of this carboxylic acid, and the amides. After that, the amides. So the amides are also the important functional derivative of this carboxylic acid. So here, as you can see, their functional formulas. So here the acyl chloride is having the RCOCl, and acid anhydride is having the RCO whole twice O. Then in the esters, it is RCOO dash, and where the R dash can be or R and R dash can be a different or the same alkyl group or the aryl group, and in amide CONH2. So in all the four as carboxylic acid derivatives, the one thing is common, that is your CO group. So here in the carboxylic acid also the CO is present, but the OH part of this carboxylic acid has been replaced by these groups that, for example, in the acyl chloride, the OH part is replaced by the Cl part. So it becomes acyl chloride. Next, in the acid anhydride, this OH part is replaced by your COR. So this OCOR, this OH is replaced by this OCOR. And in the esters, this is replaced by OR. OR part is replaced in the ester. In the esters, in the carboxylic acid, this OH is replaced by the OR. So it becomes the derivative of this carboxylic acid, that is your ester. And in the amides, this OH is replaced. This OH is replaced by the NH2. So that becomes your amide functional derivative. So it becomes a derivative of carboxylic acid, that is your amide. And these all are obtained by the replacement of your OH part of carboxylic group of acid by Cl, OCOR, OR dash, or NH2 group respectively. So here, as in the picture, you can see that carboxylic acid structure is given RCOOH, and after that, the first is that in that it is shown that OH is shown in bold. So this OH, which is shown in bold, is replaced by the Cl, and it becomes the derivative of functional carboxylic acid, that is your acid chloride. Next, in the carboxylic acid, this OH, which is shown in bold, is again replaced by the acyl oxy. The acyl oxy is your OCOR. So this replaces your OH and it becomes the derivative of carboxylic acid, and the derivative of carboxylic acid is your ester. It's acid anhydride. This is your acid anhydride where OCOR replaces your OH. Next is your OH is replaced by alloxy, and the alloxy is your OR dash. So in the OR dash, so this OH replaces the OR dash, and there is a formation of this ester. So here it becomes the derivative of carboxylic acid, and it becomes and this is called your ester. Next, in the OH is replaced, OH group is replaced by your NH2, and in your NH2, this OH is replaced by the NH2, and this NH2, and it becomes the derivative of a carboxylic acid, and it is known as your amide. So this is your amide. So here, this is the introduction of your carboxylic acid derivatives, in which these are the functional derivative, important functional derivative of your carboxylic acid, and these are your acyl chloride, your acid anhydride, your esters, your amides, which are obtained by the replacement of your OH part of carboxylic acid by your Cl, OCOR, OR dash, and NH2. If the NH2 is attached to this CO, if there is no CO, then it becomes your amines. And if there is a CO, if part is attached to this NH2, then it becomes your amide. So in this, they are all formed by the carboxylic acid. That is why they are known as carboxylic acid derivatives, and they are of 4 types. That is your acyl chloride, which is having the functional formula RCOCl. Second is your acid anhydride, that is having the formula RCO ka whole twice O. Next is your ester, which is having the formula RCOOR dash, in which R and R dash can be the same, or it can be the different also. Means one R can be your alkyl and the other R dash can be your acyl, or both R and R dash can be your alkyl. and amide. And amide. Both is the amide that is having the formula RCONH2, which has been replaced the OH, and OH is replaced by the NH2. So these are the carboxylic acid derivatives introduction. Next is your acidamide. So here in the last lecture, we have already discussed the method of preparation of your acid chloride, acetic anhydride, and the third one is your esters. So those three method of preparations have been cleared, and now the fourth is your acidamide. So in the acetamides are regarded as carboxylic acid derivatives in which hydroxyl group, that is your OH, is replaced by an amino group, that is your NH2. For example, the most common amides are methenamide and ethanamide. They have the general formula, that is the RCONH2. And the acid-amide can be prepared by the following methods. So in the acid-amides, amides amides are regarded as carboxylic acid derivatives. So as you all know that the amides are the carboxylic acid derivatives. In this amides, the hydroxyl group, the R's from the RCOOH, the OH part from the carboxylic acid is replaced by the amino group, that is your NH2. And for example, the most common amide means these are the first member of this acetamides. So these are the most common, and in this it is your methenamide. So here in the methenamide, you can see that its molecular formula is given HCONH2. So it is having one carbon. If there is one carbon atom is present, then it is having the name methane. So here E is replaced by from the methane, the E is replaced by the amide. So its name is methenamide. And second, the most common amide is your ethanamide. So from ethanamide, this is your CH3CONH2. So from here you can see there are two carbon atoms are there. So its name is ethane, and from the ethane, E is replaced by the amide. So it becomes ethanamide. So they are having the general formula. So their general formula is your RCONH2, and the acetamides can be prepared by the following methods. So some of the methods are given here. From that method, these acid amides can be prepared, and these general methods are very useful for the preparation of this acid amide. So first method is your action of ammonia on acyl chloride, acid anhydride, or esters. So here the first method is your action of ammonia on acyl chloride and acid anhydride or esters. So here, if the ammonia is attacking or showing its action on acyl chloride, that is acid chloride or acid anhydride or the esters, these are also the derivatives of the carboxylic acid. So this acid and amides is formed. So here acid amides can be prepared by the acylation of ammonia with acyl chloride, acid anhydride, or esters. So in this, the acid amides can be prepared by the acylation of this ammonia, means the acid amide is prepared. This is a method of preparation of acid amide. So they are prepared by the acylation, means here the ammonia acylation is happening here with the acid chloride, acid anhydride, or the ester. So here first example is given, that is acetyl chloride. So here acetyl, because here two carbon atoms are there, that is why its name is acetyl chloride plus 2NH3, means here we have taken the two molecules of your ammonia, and after that if they are both reacting, there is a formation of this acetamide. So in this when this acyl chloride is reacting with this ammonia, and there is a formation of this acetamide plus NH4 ammonium chloride, NH4Cl is formed here. So As you can see, this is your acetyl chloride because it is a two molecule of ammonia. So here CH3CONH2 is formed. So here you can see CH3CO, and from here NH4 is NH2 is used. So from here NH2 is used. So here CH3CONH2 is formed and NH4Cl. So here NH4 3 plus 1 4 4 NH4 plus Cl, this Cl. So it's wrong here. It's CH3COCl plus 2 NH3, and there is a formation of this acetamide, that is your CH3CONH2 plus NH4Cl. So this from here, this ammonia, the two molecules of this NH2 is formed, got attached to this or bonded to this acetyl part, and from here this Cl is removed from here and get bonded to this NH4. So there is a formation of this acetamide, and this NH4Cl is formed here. Next is here the acetic anhydride. So here acetic anhydride. So acetic anhydride formula is CH3CO whole twice O plus ammonia, and there is a formation of this acetamide. So acetamide is formed here. So here acetamide is formed here plus acetic acid is formed here. As you can see here, the acetic amide, it is having the CH3CO whole twice, means these are the two molecules. So one molecule get attached to this NH2, and from here one H is all out, and CH3COOH is attached here, and there is a formation of this acetic acid is formed. Next is your ethyl acetate. So from the ethyl acetate, the ethyl acetate plus ammonia, so it is your CH3COO C2H5 plus ammonia. So there is a formation of this acetamide plus ethanol. So in this, the ethyl acetate, that is having the formula CH3COO C2H5 plus NH3. So here, this CH3CO part will get attached to this NH2, and after that from H, that is this removed from this ammonia, get attached to this C2H5O, and it get attached to this OH. So in this case, there is a formation of this ethanol. Again, I am telling you this reaction, first method of preparation of this acetamide. So in this acetamide, there is the action of ammonia on acyl chloride or acid anhydride or esters, and there is a acetamide is formed. So acetamide can be prepared. This acetamide can be prepared by the acylation. Means here the ammonia is doing the acylation of this with the acyl chloride, acid anhydride or esters. So in the first example, there is a acetyl chloride in the ammonia. So here you can see that this is your CH3COL. From here, when it get dissociated, it will dissociate it into CH3CO negative plus Cl positive. So here it is getting the NH3. So NH2 is removed out from here, and after that NH4 is there. The NH4 get the positive charge, and this will get the NH4 get the positive charge, and this NH2 is getting the negative charge. So here it is getting the positive, and this is getting the negative. So this positive will react with this negative portion of the CH3O, and this will react with this. There is a formation of this CH3CONH2, and this negative Cl will react with the positive NH4, and there is a formation of this ammonium chloride. Next is the acetic anhydride. So in the acetic anhydride, what we see that the CH3CO will be moved out from here, and it will get attached to this NH2, and there is a formation of acetamide. After that, this CH3COO will react with this H positive, and there is a formation of this acetic acid. So this NH2 is having the negative, and this CH3CO is having the positive charge. So it gets attached, both of them bonded, and there is a formation of this acetamide. After that, this ammonia, in the ammonia, this NH2 is having the negative, and this H is having the positive. This H positive will react with the CH3COO negative. There is a formation of this acetic acid. Next is your ethyl acetate. So in the ethyl acetate, you can see that this CH3COO C2H5 will get dissociated, and this NH3. So NH3 get dissociated into NH2 negative and this H positive. So here CH3CO and this C2H5O negative will dissociate from here, and it will get attached to this H positive, and there is a formation of this ethanol, plus there is a formation of this acetamide. Next reaction is your by heating ammonium salts of fatty acid. So in this case, there is a heating of ammonium salt, of fatty acid. The ammonium salts of carboxylic acid or heating give amide. So here this acetic acid is reacting with this ammonia, and there is a formation of this salt of ammonium acetic acid, and when we will heat it, there is a formation of this acetamide, the water molecule. So by heating ammonium salts of fatty acid, so this CH3COONH4 is the ammonium salt of fatty acid. So this fatty acid is on heating, it is dissociating and it is forming a acetamide as well as your water molecule. So in this, by heating ammonium salt of fatty acid, firstly the ammonium salt of carboxylic acid has to be formed. So this forms from the acetic acid plus your ammonia. So from the acetic acid plus ammonia, this ammonium salt of carboxylic acid is formed, and from the acetic acid and NH3 get attached to it, and there is a formation of this ammonium salt of carboxylic acid, which on heating, after that it got heated, and there's the heating, it gives your acetamide plus water molecule. So acetamide is your CH3 CONH2 is formed here, that is your acetamide plus water molecule is formed here. Next is your partial hydrolysis of cyanides. So in the partial hydrolysis of cyanides, you can see that the partial hydrolysis of cyanide with concentrated hydrochloric acid or polyphosphoric acid or alkaline peroxide produces amide. So here the partial hydrolysis of cyanide with concentrated HCl, if we can hydrolyze the cyanide with the hydrolysis means there is a water hydrolysis there, means there is a water molecule. So with that hydrolysis, we are also using the concentrated HCl. We can use that HCl, concentrated HCl, or polyphosphoric acid or alkaline peroxide is also used. After that, there is a formation of this acetamide. So in the partial hydrolysis of cyanide, the partial hydrolysis of cyanide with concentrated hydrochloric acid, polyphosphoric acid, or alkaline peroxide produces your amide. So here you can see in the reaction, this is your acetonitrile. So in the acetonitrile, you can see this is your CH3CN. CN is your nitrile. So CH3. So this is your, because there are two carbon atoms are there, that is why we are using a acid. So here acetonitrile plus water molecule, and then it is reacting with the alkaline peroxide. It is reacting with the alkaline peroxide, and there is a formation of the acetamide is formed. So acetamide is formed here. So partial hydrolysis of cyanide. So again, I'm telling you the second and the third reaction. So in the second reaction, you can see that by heating ammonium salt of fatty acid. So we have to heat the ammonium salt of fatty acid. After that, there is a formation of this acetamide. So this ammonium salt of fatty acid is produced by the reaction of the acetic acid plus ammonia. So it by the reaction of this acetic acid and the ammonia, there is a formation of this ammonium salt of fatty acid, ammonium salt of carboxylic acid, and on heating that we are getting this amide. So here you can see the reaction, acetic acid plus ammonia is getting reacted, and there is a formation of this intermediate, that is ammonium salt of carboxylic acid. So CH3COONH4 is the ammonium salt of carboxylic acid, and when we are heating it, When we are treating this CH3COO and its 4, then there is a formation of this acetamide plus water molecule is formed here. So water get evolved out from here. So from here you can see CO, burnt water, O is removed out from here, and two molecules of hydrogen is removed out from here, and there is a formation of this H2. Then the partial hydrolysis of cyanide. So in the partial hydrolysis of cyanide, the partial hydrolysis of cyanide with concentrated hydrochloric acid, polyphosphoric acid, or alkaline peroxide produces amide. So here we are showing this example with the help of this alkaline H2O2. So in the H2O2, acetonitrile, that is a CH3CN plus water molecule, CH3CN plus water molecule, that is acetonitrile plus water molecule uh, plus alkaline H2O2, there is a formation of this acetamide formed here. So the next reaction is your reaction of an acid chloride with an amide. So in this, the reaction of an acid chloride with an amide, acid chlorides are converted into your primary, secondary, tertiary amides by the reaction with ammonia, primary amines, and the secondary amines respectively. So here in this is the fourth reaction of your acid amide. Yes, acetamide. So here we are reacting the acid chloride are converting into your primary, secondary, and the tertiary amide by the reaction with ammonia. So here we are reacting the acid chloride with the ammonia, and there is a formation of this primary amide plus HCl is formed here. So in this, the primary amide, you can see here that when acid chloride is reacting with ammonia, there is a formation of primary amide, that is your RCU2NH2 plus HCl. So acid chloride plus ammonia is reacting with primary amide. Secondly, acetyl chloride is reacting. Here the example is given in which acetyl chloride is given plus ammonia is reacting. After that, there is a formation of this acetamide is formed plus HCl is formed here. So in this, acetyl acid chloride plus ammonia is reacting to form the acetamide plus HCl. Next is the aryl benzoic acid. No, this is your benzyl chloride. So in the benzyl chloride, when benzyl chloride is reacting, which is an aryl product, is reacting with the ammonia, so there is a formation of this benzamide is formed here. So in this, the benzyl chloride is reacting with the ammonia, and there is a formation of this benzamide. Plus HCl is formed here. Next is the acid chloride. So here acid chlorides are converted into your primary, secondary, and tertiary amide by the reaction with primary amines, ammonia, and the secondary amine. So here we are taking the example first. In this, the first is your acid chloride. So in acid chloride with the reaction of acid chloride with ammonia, we are getting here primary amide. So here we get the primary amide. And when the acid chloride is reacting with the primary amine, so here when the acid chloride reacting with the primary amine, then there is a formation of secondary amide. So secondary amide is formed plus HCl is formed. So here the example is given, that is your acetyl chloride plus C2H5NH2. This is your primary amide, and then primary amine is reacting with this acetyl chloride. There is a formation of this N-ethyl acetamide. So there is a formation of this N-ethyl acetamide is formed plus HCl is formed here. So CH3COCl plus C2H5NH2. So there is a formation of this CH3CONH, C2H5 plus HCl is formed here. So acetyl chloride is reacted with the primary amine, and there is a formation of this N-ethyl acetamide is formed. Next is your acid chloride. So in the acid chloride, the secondary amine, acid chloride is reacted with the secondary amine, and there is a formation of tertiary amine. So acid chloride is reacting with the secondary amine, and there is a formation of this tertiary amine. So here you can see that in the fourth reaction, I am again telling you that in this reaction, the acid chloride is reacting with amine. So this acetyl chloride is reacting with this amine, and when this acid chloride is converting, this acid chloride is converting into your primary amide, secondary amine, and the tertiary amide. And by reaction with your ammonia and reaction with primary amine and the secondary amine. So in this acid chloride, you can see when it is reacting with ammonia, then this SrCONH2 is formed, and from here H is revolved and here Cl is removed. So here there is a formation of this HCl. Next, in the acid chloride RNH2, there is a reaction with this RCO and NHR. So, and from here H is removed out and HCl is formed there. So there is a formation of this HCl. Next is your acetyl chloride. So here acetyl chloride example is given. Acetyl chloride is reacted with this C2H5NH2, and there is a formation of this N-ethyl acetamide. Next is your RCOCl. When RCOCl is reacting with this primary amine, secondary amine, there is a formation of this tertiary amide is formed here. Tertiary amide is formed from this acid chloride. So here you can see this Cl and this H is form a HCl, and this RCO and R2 is formed, and there is a formation of this tertiary amide is formed here. So there are the four methods for the preparation of this acid amide. So in the first reaction, there is a reaction of ammonia or ethyl chloride, acid anhydride, or the ester. Next is your by heating ammonium salt of fatty acid. First we have to prepare the ammonium salt of carboxylic acid. After that we are heating it, then there is a formation of this acetamide plus water molecule. Next is the partial hydrolysis of cyanide. So here the cyanide is reacting with the water molecule, or there is a hydrolysis of this cyanide with the alkaline H2O2 peroxide, or in place of this alkaline peroxide, we can also use the concentrated hydrochloric acid or the polyphosphoric acid, and there is a formation of this acetamide. And in the next reaction, that is the last in this, we can form, there is a reaction of an acid, there is a reaction of an acid chloride with an amine, and this acid chloride is reacted with the ammonia, and there is a formation of the primary amide. When acid chloride is reacting with the amine, then there is a formation of the secondary amide, and when acetyl chloride is reacting with the secondary amine, there is a formation of the tertiary amide. Next is the chemical reaction. So in the chemical reactions of carboxylic acid derivatives, firstly, the acyl chloride are most reactive derivative of carboxylic acid, and they easily undergo nucleophilic acyl substitution to form acid anhydride, esters, and amide. And the most common acyl chloride are methanol chloride and ethanol chloride, and the acyl chloride gives the following chemical properties. So here in the acyl chlorides, these are the most reactive derivatives. These are the most reactive derivatives of the carboxylic acid, and they usually undergo nucleophilic acyl substitution, and there is a formation of acid anhydride, esters, and amides. So in this, the acyl chlorides are undergoing nucleophilic acyl substitution. So here the nucleophilic substitution reaction is occurring in this acyl chloride, and these are the most reactive derivatives of the carboxylic acids, and they are forming acid anhydride as esters and amide by the nucleophilic aryl substitution reactions. And the most common acyl chlorides are your methanol chloride, that is your HCOCl, and the ethanol chloride, that is your CH3COCl, and the acyl chloride gives the following chemical properties. So the following chemical properties in this, the first is the basic character. So the basic character, the acyl chlorides are very very much less basic because the chlorine atom is not effective at stabilizing a positive charge. So in the acyl chloride, the formula is your HCOCl. So in this, the CO, when O is having the partial negative charge and C is having the partial positive charge, and chlorine itself is the electronegative property. So here in the acyl chlorides, these are much less basic. So they are not basic, they are much less basic because the chlorine atom that is attached to that chlorine atom that is attached to your carbon is not stabilizing the positive charge that is present on the carbon atom. That is why these acyl chlorides are showing the a property of much less basic, because the chlorine that is attached to the carbon atom that is not effective at stabilizing a positive charge. Next is the reduction reaction. So this reduction reaction means the acid chloride get reduced to aldehydes by the action of hydrogen in presence of palladium base barium sulfate. So in this, the acid chloride is reduced and there is a formation of aldehyde by the action of hydrogen. Hydrogen is added. Reduction means there is the addition of hydrogen, and in this the addition of hydrogen is occurring. So on the acid chloride there is the addition of hydrogen is occurring, and in the presence of your palladium barium sulfate plus xylene. So in this, the CH3COCl plus hydrogen is reacting in the presence of your palladium and barium sulfate, and in the presence of xylene also there is a formation of this acetal aldehyde plus HCl is formed here. So in the acyl chloride, these are the most reactive derivative of the carboxylic acid derivatives, and they usually undergo nucleophilic aryl substitution reaction to form acid anhydride esters and the amides. And the most common acyl chlorides are the methanol chloride that is having the formula HCOCl, and second is your ethanol chloride that is having the formula CH3COCl, and the acyl chloride gives the following chemical reaction. That is, the first is your basic character, that they are very much less basic because the chlorine atom is attached with the carbon atom, which is not stabilizing the positive charge of the carbon atom. These chlorine atom is not effective at stabilizing a positive charge. That is why they are showing a much less basic character in them. Secondly is the reduction reaction. So in the reduction reaction, the acid chloride get reduced to aldehyde by the action of hydrogen in the presence of the palladium sulfate, and in this CH3COCl plus hydrogen. So palladium barium sulfate in the presence of acetyl chloride is reacting with the hydrogen in the presence of palladium barium sulfate, and also in the presence of your xylene. Then they are forming acetyl aldehyde plus HCl is formed here. So this is the first. Second is the hydrolysis. So in the hydrolysis, you can see the acid chlorides are hydrolyzed with water to parent carboxylic acid, and there is the formation of the acetic acid. There is a formation of this acid. So in the hydrolysis, the acid chlorides are hydrolyzed with the water to form the parent carboxylic acids. And as you can see, the acetyl chloride, which is acid chloride, is hydrolyzed in the presence of the water molecule, and it is hydrolyzed into your acetic acid plus your HCl. So here, the acid chloride, which is the carboxylic acid derivative, is hydrolyzed into the parent carboxylic acid. So in this also benzoyl chloride, this benzoyl chloride is reacting with the water, and there is a formation of this parent carboxylic acid plus HCl is formed here. Next is the action with ammonia. So in the action with ammonia, acid chloride is reacting with ammonia, and there is a formation of acid amide, that is your acetyl chloride plus ammonia, and there is a formation of this acetamide is formed plus HCl is formed. So in this, the acid chloride is benzoyl chloride is reacting with the ammonia, and there is a formation of this acid amide. So from acid chloride is getting converted to your acid amide. So in this, the reaction of this acid chloride with the ammonia, there is a formation of our acetamide is formed here plus HCl. So the first is your basic collector, second is your reduction, third is your hydrolysis. So in the hydrolysis, the acid chloride are hydrolyzed with water to parent carboxylic acid, and the acetyl chloride is reacting with the water, or you can say the acid chloride is hydrolysis. On hydrolysis of this acetyl chloride, there is a formation of a parent carboxylic acid is formed plus HCl is formed. Next, in the aryl also the benzoyl chloride on hydrolysis, it is forming a parent carboxylic acid plus HCl is formed here. Now, next is your action with ammonia. So in the action with ammonia, acid chloride is reacting with the ammonia to form acid amides, and you can see here that the acetyl chloride is reacting with the ammonia. There is a formation of this acetamide plus your HCl is formed here. And in the aryl also, this benzoyl chloride is reacting with ammonia, and there is a formation of this acetamide is formed there. It means here that there is a formation benzoamide is there plus HCl is formed here. So these are the reactions of this acetamide. Next is the fifth reaction, chemical reaction of this acid chloride. So action of amines. So here acetyl chloride is reacting with the amines, primary amines. So there is a formation of the acid amides. So here you can see that the acetyl chloride is reacting with the primary amine, and there is a formation of this acetamide is formed here. Ethyl and ethyl acetamide is formed here, plus HCl is formed there. Next is your acetamide, benzoyl chloride is reacting with this primary amines, and there is a formation of this benzoamide is formed here. So N-ethyl benzoamide is formed here, plus HCl is formed here. Next is your formation of acid anhydride. So in the formation of acid anhydride, the acid chloride, by treating with sodium salt of fatty acid, produces anhydride. So here acetyl chloride is reacting with the sodium acetate, and there is a formation of this acetic anhydride is formed here, plus NaCl is formed here. So when benzoyl chloride is reacting with the sodium salt of acetic acid, that is the sodium acetate, there is a formation of this methyl phenyl anhydride. So methyl and phenyl anhydride is formed here, plus HCl is formed here. So the fifth reaction of this acid chloride is the action of amines. In this, the acid chloride on reaction with primary and secondary amines give acid amide, and in this, the acetyl chloride is reacting with your primary amine, and there is a formation of an N-acetamide plus HCl. So here, as benzoyl chloride is reacting with your primary amine, and there is a formation of this ethyl acetamide plus HCl, and sixth is your formation of acid anhydride, which is reacting. Acid chloride is reacting by treating with sodium salt of fatty acid to produce anhydride. So here acid chloride is reacting with the sodium acetate. There is a formation acetic anhydride. In the aryl, the benzoyl chloride is reacting with the sodium acetate, and there is a formation of methyl phenyl anhydride. is formed. So in the next is the next. So here the questions are, first question is, your anhydrides can be converted into esters by the reaction of alcohol's reduction of acetyl chloride with BDBSO4 to produce acetaldehyde. Next is on reduction with lithium aluminum hydride. Acetic anhydride produces alcohol. On reaction with thionyl chloride, esters are converted into acid chloride. Next, with lithium aluminum hydride, amides reduces to acids, and the anhydrides can be converted into ester with the reaction of amines. So next is your acetamide can be obtained by the partial hydrolysis of cyanide, and on reduction with lithium aluminum hydride, acid anhydride produces alcohol. So these are some of the references from where you can study this topic, and thank you so much for today's lecture.